Okay, so hello everyone, welcome. Can you hear me? Hello.
Yes, we can hear you.
Okay.
Yes, sir,
Just
we
we
can
are
hear you.
waiting some 1 or 2 minutes for joining all of those other participants. Then we'll start our today's session. Okay, so now we'll start our today's session. So basically today I will try to discuss about that change detection, how we can easily perform the change detection analysis using Google Earth Engine platform. Mainly land use, land cover change detection, then NDVI change detection. Okay, so then how we can easily calculate it up, the transition area for the different time period, how we can easily calculate about that. Okay, so before starting that, we try to discuss about the problem solving. Okay, so when you if you face any problem regarding
Sir,
then we discuss. Yeah,
I
please.
have sent you my code. Can you please open that?
Yeah, what is the problem you face? Let me check. Okay.
And please share your screen. We cannot see you.
Let me share my screen. Okay, so now it's visible. Yeah, can you see my screen now? Yeah.
Yes, sir.
Yeah. Okay. Okay. So what is the problem you face in here?
So I just want to ask you something that I didn't face any problem, but when I use the classifier random forest, different there were different points which we have to be.
Yes. Yeah, I cannot hear you properly.
You can see that I put all these variables. So I
Yeah,
just
yeah.
want to know about these values on.
Okay, so how we can determine about that? Suppose number of trees is the 50 is the best for this model. And how you can calculate this? The number of trees for this model 50 is better. Okay, so do you calculate that number or randomly put?
I just randomly add that.
Yeah, so that's why in this time we face the problem. Okay, so in this time we have to follow the some
But my
process about that.
accuracy is overall 100%.
No, it's not, it's totally wrong about that. So in this time sometime it also show about the 100% accuracy, but it's not 100%, because 100% accuracy for land use land cover classification for the remote sensing purpose is totally not possible. For getting the 100% and there is a no error is totally not possible. Okay, so for that for that in this time it's showing the 100%, one is the 100%, but any remote sensing analysis, not only for this land use land cover or anything about the remote sensing analysis, is not possible to acquire the 100% accuracy. Okay, we can get the some 0.1% error at least. Okay, at least 0.1% error is always we can get in here. Okay, so in this time we face again some simply can simply put the number of trees and variable per spilled and mean leaf population 3, brag fraction 0.5, max node you can put at the 100, seed you can put at the 0. Okay, so first of all you have to learn about that how we can easily get the better number of trees for the class of 50. Okay, what is the for this model, what is the accurate result for that number of trees? If you want to simply, you can simply go in here. Suppose I simply show you that algorithm, and today's class I also try to cover this part how we can easily get this type of value. So basically it's the different for the different. Okay, so here you can see the number of trees. Okay, first of all we have to identify what is the accurate number of trees for my model. When I use that I can get the best accuracy or better accuracy. Okay, so for that we have to use here the we have to find out the hyperparameter tuning for this model. Okay, and it's the different for the different land use cover classification, you can get the different number of trees is the better for that. And then also you can see the variable per spilled. In this time it mainly identify about the number of variable per spilled. If unspecified, use the square root of the number of variables. Okay, and if you want you can use here the default. So default it is a null value. If you want to use here the null value, so there is the no problem. Okay, default null, it's showing the result for the default. If you want to use the null value, so there is the no problem, or mainly a null value is the unspecified. Okay, and then mean leaf population, it's mainly integer value. And default, if you want, suppose in this time I just only use the number of trees and did not use other types of variable, then it automatically set the default value. Suppose I did not suppose mean leaf population I did not define it, so it automatically get the default one value and then make the calculation. Suppose bug fraction, suppose in this time if I don't use any types of value for the bug fraction, it automatically defaultly set about the half or 0.5. Okay, suppose also in the max node, so mainly is the maximum number of leaf nodes in each tree. Okay, and if you want, if you don't use any value, then it's default no limit. Okay, you did not put any limit about the maximum node. Suppose I put here the only for the suppose 10. Suppose in this time we can put here the suppose max node, suppose 1000. Okay, so you set the limit in this timing here. So in this time, suppose in this model I also need to the more than 1000 node, I need the more than 1000 node. So but you simply set the maximum node will be 1000 in this time. So that's why in this time it not take the other maximum node. So in this time when you want to default this model, it automatically take all of those node which this model for need. Suppose more than 100 or any value which you need, it automatically get from here. And also in the seed, so mainly the seed is the integer value, it is the non-randomization of the seed, and default in this time it show the result for the 0. Suppose in this time I did not use any seed value, then it automatically get the default value as a 0 and then make this classification. In this classifier, this number of trees is very important for that. Okay, So that's why in this time I also show you the for further time how we can easily calculate it, the number of trees for a specific model. Okay, another thing is the default. If you want, there is a no problem about the fraction 0.5 is no problem. Max node, if you want to use that the no value, there is a no problem. Okay, so there is a no limit. We did not set any limit for the maximum node. Suppose in this model, it create the suppose 20,000 node. Okay, then it automatically create the 20,000 node and make this land use land cover classification about that. Okay, so I will show you that for the today's session also how we can easily calculate the number of trees and then put the accurate number of trees for any specific land use land cover classification model. Okay, then I hope you can easily get the idea how we can easily find out the number of trees value.
Okay.
Okay.
Ji, sir.
Okay, so I'll show you the later about that.
Okay, sir.
Okay. And what is the unit of the total calculated area in the previous class? It is a hectare. Yeah. So mainly when you multiply 10 into 10 inverse 4, 1 into 10 inverse 4, then it automatically calculated the hectare. Okay. Multiply 1 e inverse 4. Okay. So it automatically calculates. Suppose
when we multiply with 1 e minus 4, it means that we convert it to hectare. But
yeah,
what is
hectare.
default area?
What? Don't
What
understand.
is
Default is
area? If
the default is meter square.
You don't understand about that. What is the fault?
No, he's asking
Yeah,
before
yeah.
you change it into hectare, what is the default unit of the area?
Square
We
meter,
calculate
square
it.
meter, square meter.
It's
Okay.
the square
So
meter.
square meter. We just convert to square meter to hectare. Okay. Then simply multiply with 1 inverse 4. Suppose you can see. Suppose square meter to hectare. So we can get, you can see, if you want, you can divide it this value, or if you want, you can multiply this value, same result. Okay. Suppose you just simply divided the 10,000, then we can get the result in hectare, or multiply with this value, then we can get the result hectare. Okay, same.
Okay.
Okay. So now let's anyone any question or any problem for the regarding class? Okay, so now let's jump to our today's session. Okay, just I simply open my slide. Yeah. So basically today I will try to discuss about that how we can easily make the land use land cover change detection analysis using the Google Earth engine. And when you want to make the land use land cover change detection map, we have to need the 2-decade map. So that's why in this time I also try to cover the part how we can easily make the multi-year satellite images. Suppose how we can easily get the different year or annual image collection. Suppose I need the image for 1992 2023. Okay, so how I can create the all of those annual image collection at the same time. So these things I also try to cover this session, as well as I also try to discuss about that NDVI change detection, how we can easily find out the NDVI change detection. Then how we can easily make the class-wise land use land cover change detection class-wise. Suppose urban, water, build up. So this type of class-wise change detection, how we can easily do in one layer in Google Earth Engine platform, and how we can easily improving our accuracy in machine learning, mainly hyperparameter, how we can easily find out the what is the actual value of the number of trees and then get the result. So basically this all of those things I will try to cover for the today's session. So let's go. Okay. So first of all, I try to discuss about that land use land cover change detection. So for the practice example, I already, you can see I created my study area. So this is my study area. So in this study area, I just try to add the different yearly or annual image collection. Here you can see this is the image for okay, I show you the problem. So this is the image for 2021 Lancet image collection. This is 2021. This is the image collection for 2011. This is the image for 2001. And mainly annual image collection. And also you can see this is the image for 1901. Okay, so you can get total 4 years annual image collection, mainly annual median image collection. It is the annual median image collection. Okay, so first of all I will try to show you that how I can create this type of annual image collection, okay, for the different time or different year using the Landsat imagery, mainly Landsat 5, Landsat 4, 5, 7, and 8. How we can easily combine and then create this type of annual image collection, such as Landsat 1991, Landsat 2001, 2011, and 2021. Okay, and using this process, you can easily create any time period land use land cover classification for any time interval. In this time, I can create this time interval is at 10 years. Okay, so now let's go about that how it will be work and how I can create this type of image collection, annual image collection for any region, not only for that, any region, how we can easily create. Okay, so let's go about that. Yeah. So in this time, what can I do? I just try to explain one by one. So first of all, this is my study area. About that, suppose we can easily import it our boundary shape file. And this is my study area. I already imported the boundary shape file in the asset tab and simply import it in my Google Earth Engine platform. Okay, or it also better if I want to show you the another region, then you can easily only relate it the work how we can easily put this code for another region. It also better. Okay, so let's go. I show you that. Suppose in this time I want to need the Landsat annual image collection for the Dhaka city region from 1991 to suppose 2021. All of those interval is the 10 years. Okay, so how I can get that? First of all, simply click on the asset tab and you can simply get the, you can see the Dhaka. Okay, just I simply import my study area. Okay, so in this time I just use here the same variable name as a shapefile variable name. I put the name is that AOI. Okay, so now just simply show the layer map.add layer function as a AOI and also just center map.center object with AOI. Suppose zoom level is the suppose 6 and click to run. So now I can get my study area of Dhaka city. So now for this Dhaka city, I want to need the Landsat image from Landsat image. Suppose Landsat image 1991 to 2021 annual median image. Okay, suppose each year median image I want to need for this study area. So for that, what can I do? First of all, I can simply call my image collection and filter the image collection for Landsat 4, 5, 7, and 8. Okay, so I simply use the same code for this region. And in this time here, you can see, first of all, okay, so I explain the code later. So I remove the cloud and haze from the satellite images. And here, suppose first of all, I simply create this type of things. I want to simply, suppose I simply put here the start year, suppose 1990, and end year, suppose 2021. Okay, and now I make a years. I take a variable years and make the list sequence. Okay, so mainly now here you can see when I print that I can get the all of those year sequence in a list from total 32 years. Okay, from 1992 to 2021, I make the list for total, you can see 32 years. Okay, image I make the sequence. I need for the each year median image collection or annual median image image I want to need for that region. So just I simply get this type of result from here. And now also you can see in this time, I just simply, in this time, this is my band about that. In this time, I use here the Landsat 5, 7, and 8. So I just simply put here the band name, all of those band name, Landsat 5, 7 and 8. Basically, you can see Landsat 5, Landsat 7, and Landsat 8. So mainly Landsat 5 and Landsat 7, you can see the band name is the same. Okay, you can see Landsat 5 and 7, mainly B1 is the blue, also B1 is the blue, B2 is the green, also B2 is the green, B3 is the red, and also B3 is the red in here, you can see. Okay, also you can see we can get the result, all of them is the same. In this time we can get, in this time we are just put here the band, and also put here the band name also. We are also put here the Landsat band, and also put here the band name. Okay, so B2 is the blue, B3 is the green, B4 is the red, B5 is the near infrared, B6 is the short wave infrared, B7 is the short wave infrared 2, and pixel QA. So in this time I just simply put the band and band name together at the same time in this time add. So in this time, so further we are easily use the band name. Suppose blue, green, red, near infrared, short wave infrared, we can easily use it, not use the B1, B2, B3. So for this region, at the same time we create the two list, one list for the band and another list for the band name. Okay, so for the future we can easily use this type of band name, and we can easily make for the band combination or other things we can easily do from here. Okay, so now I simply put here all of those band for this Landsat 5, 7, and 8, and then I need to call all of those image collection. Okay, so here I already create this type of image collection, such as you can see the satellite imagery for Landsat 8, Landsat 7, and Landsat 5. I simply copy the full all of those image collection from here. So in this time I simply paste in here. So here you can see the Landsat 8, just simply call my image collection, then filter metadata. In this time here you can see I put the less than 15%. Okay, if I want I can also put here the less than 1% for this region. There is no problem, because in this time it's not very cloudy region for that Dhaka city. So in this time anyone, they can easily use the code for any region, suppose coastal region or other coastal land. So that's why in this time I put here the 50% of cloud cover. Okay, so 50% when I use here the 15%, then it take the all of those 15% cloudy image as a cloudy region also. Okay, in this time when I increase the value, then I also need to remove the cloud from these satellite images. Okay, and previous class I also show you that for the Sentinel-1 imagery how we can remove the cloud. So mainly when you increase the value, we find out some cloudy pixel. So this type of cloudy pixel we can easily remove using the cloud marks band function. Okay, so in this time we are also put here the cloud marks band function. So basically you can see I already create the function in here, and mainly cloud marks band function is the same for Landsat 457 all time. Landsat 457 cloud and haze remove function will be same. Okay, and it's also some different for the Landsat 8. Okay, so in this time you can see we can get this type of format, but we are also use this type of same format for our function creation. Suppose I just use here the var keyword and put here this and click here. Okay, so it was the same, there is no problem. In this time this is the function variable name, and also this is the function variable name. So basically this function remove the cloud and haze from that Landsat 457 ms, and this function remove the cloud only for the cloud and haze, remove for the Landsat 8 satellite imagery. Okay, so how I can do that? Simply copy this function, only copy the function and paste here. Suppose I paste in here, just paste. Okay, so in this time what can I do? Just I simply use here the map function. Suppose I simply copy the function variable name, simply copy and add with my collection. For collection we just use here the map function. You can see this is the map function, and put here the function variable name which I created. And also the same, also you can see select L8 bands and band name. Okay, so in this time here I select the L8 bands and band name. Okay, so that's why in this time it show the band name. Okay, in this time when I run the code I can get all for the band name blue, green, red, near infrared, not show the band number B2, B3, it's not showing, because I use the Landsat bands and also use the corresponding their name in here. Okay, so in this time I create the collection about that all of those land set. Okay, same approach I simply apply, and now I need to merge for the land set 4 5, and I need to merge in here. Okay, so any question, please? Yeah, please. Any doubt, please?
Sorry, can I ask, because I understand that we set the years from 1999 to 2021, but under the, I can see under the Lancet A8, the year shows from 2012.
Yeah. Basically, it's
So is it?
depend on your
Yeah.
image collection time period. Okay, suppose here
Okay,
you can see,
thank you.
you can find out the image collection. Suppose, so just I simply take a variable about that. Okay, just a minute. Yeah. Okay, in this time I simply merge all of those image collection together. So for that, I simply copy this code from here and then paste. Okay, in this time here you can say I take a variable is a full collection. I simply take a variable as a full collection and then put here the variable name L8 merge with L7 and L5 merge with L5. So now I check how many collection I can get in here. Total, all of those image collection, Lancet 8, 7, and 5. How many collection I can get for my study area? Here I can get total 439 image collection. Okay. Here I can get total 439 image collection. I can get in here 439 image collection. In this time, anyhow, I need to convert all of those image collection into annual image collection. Okay, or annual image collection. Suppose 439, just convert into annual or yearly. Okay, and how I can what is the year about that? I already defined my years. You can see years variable already stored 32. Okay, so now this 439 image collection, from here I need to convert it 32 years or annual image collection, from 39 to 30 years image collection. So for that, what can I do? It very easy. For that, in this time we are use a function from image collection. You can see the function I simply write from. Yeah, you can see in this time we have to use the function image collection from image. Okay, so in this time mainly this 439 is a image collection. Okay, so from this image collection I am to convert into other, in this time annually, and I already defined my annual total 32 years. Okay, total 32 years. So in this time we have to use the function, and mainly it return the image collection containing the given image. Okay, so in this time it return the mainly from this function I can got the image collection containing the given images. So mainly in this time I can get the annual image collection, which I set annual median image collection. In this time I need to set, and then we can, in this time here you can see argument is the images list. Okay, in this time your argument is the images list and the image to include the collection. Okay, and this image must include in the collection. Okay, so let's go how it will be work for that. Okay, just I simply copy the same code from here, simply copy and then paste. And here you can see the result about that. So in this time, what can I do in this code? It's very important for that conversion. In this time, from this image collection, mainly 439 image collection, I need to create the annual median image collection. Okay, so for that I simply use this function. Okay, this is my function, and then I also create the function. Okay, you can say simply create the function. Okay, so mainly function, what happened? So mainly in a function we have to define an element name. Okay, we already discussed about the function. In this time, this is my function and this is my element name. Suppose I take the element name as a ER. Okay, and now I simply put my argument, okay, in the curly bracket. In this curly bracket, I put my argument. In this time, what is my argument? In this time, my argument is that this 439 image convert yearly median image. Okay, and this 439 image is stored in this variable full collection. Okay, this 439 image is stored in the full collection. So what can I do? I simply take a variable name, suppose annual. You can use any variable name, and then call the full collection, which is including 439 images, and filter it. How I can filter? I want to filter yearly. Suppose 2001. Also put here the 2001, and unit will be year. Okay, unit in this time it is the unit. In this time you can say simply copy the function and show you that. Even here, you can see in this time what happened. So basically, it return a filter, and in this time we can get the result start and end, and then we have set the field about that. Mainly in this time I need the yearly, so I put here the year. Okay, sometime we need the conversion for the monthly, put here the month, or hourly, minute, day of the year. So a lot of things we can easily get from here the field. So in this time I just simply set the year start and end, and the yearly, I need the yearly. Okay, then what I need the median, so use at the median, and then clip with my function. And finally, from this function I return the annual set as the year. Okay, so this is my function. Okay, this function I need to connect with my total 32 years. Okay, this image can need to connect with my total 32 years. So here I already make the 32 years. You can see I already create the list about the 32 years. So for that I simply copy the years and paste here, and use the map function for connecting that. Okay, simply use the map function for connecting with my function. So now it connected. So now finally I print how much annual collection I can got. So in this time we can get the total 32 years. Okay, so now this 439 image collection convert into 32. So here you can see. Now we can get the total 32 years featured from here. And all of the images have the total 7 bands. Okay, so please, any question? Okay, any question? Okay. So now here I can get.
Yes, sir. I want to ask that.
Yeah, please.
If we don't want the
Which one? I cannot hear you. You are muted. Cannot hear you. Yeah, please.
Sir, if we just want to get the image of only a specific month for these different years, not the mean image for the whole year. For example, if we want to make the LULC change detection for specific wheat season, or we can say for rice season, then we only need the image for that specific months only, rather than the yearly image. So what we can do for that?
Okay. So for that, suppose in this time, if I also need to take the another variable in here. Suppose I define the years. In this time, we also make the list of month. So just take a variable, suppose month. Okay, and then put here the same things, ee dot list dot sequence, and you have also need to mention about the month. Suppose take a variable. So suppose put the month. Suppose I need the image for January to suppose April. Okay, so just take a variable, suppose January, and for the January use here the 1, and take the variable, suppose April. For April, you add the 5. Okay, sorry, 4. Okay, just simply put that, and then, or you can write the proper way is that you can simply put here the start month, put here the in month. Okay, it is better for that in month. Okay, so start month and in month. So then for that, simply copy from here and paste, and in month also paste in here. Okay, so now you can check about your months. Then this time you can get the January to April. You can see. Okay, January, February, March, April. So in this time, what can I do? In this time, we need to also create about the another parameter. So in this time, from this full image collection, you need to just extract the satellite image. So for that, okay, you can see it will be start from here, this function. Yeah, this is the last. So from here you have to need the another function. Suppose in this time, take the variable. Sorry for that. So in this time, our year will be same. So year mainly all of this year will be same, and but I need the image for the only for January to April. Okay. So for the we have to just put here that these things in here. Just put here the another filter option. Filter Earth Engine filter dot calendar friends, and then put here that. Okay, so okay, it's not possible because in this time we are talking only for the one element. Okay, so we have to use here the different element for that. So just show that. Okay. Let me check another code. How to get the monthly and yearly for the specific month for the yearly. Yeah. Suppose, okay, so I show you this example from here and then just try to use the code in here. So basically in this code, I just will run that. Okay. So for that we have just take the months and make the list of sequence. Suppose you can put any specific month for here or any specific range. In this case, I take the January to December, and then Okay, then use the same function e.image collection from image. And first of all, ER is the annual. Okay, so in this time take the annual mean for the precipitation and then set with the year as okay. So we have to use the different. Okay, we have to use the different function also for that. Yeah. So in this time, simply copy the same code from here. For that monthly, simply copy and try to adjust the code in here. So just paste here. Okay. So in this time, what happened? Suppose, yeah. So monthly precipitation. Suppose we can use the monthly image about that, or no problem about it. So in this time, okay. And in this time, we are just put here, suppose just put here the months as a suppose January to April. Okay, that's easy. That's sensible. And then okay. Okay. So in this time we have to change it. In this time we have put here the full image collection. Simply copy, paste. Okay. So in this time we filter it the year and take the median. Median. Flatten. So now, yeah. So we use the same variable name. There is no problem. Simply copy. Now if you run, we check what the result we can got. And here we can get the total 128 image collection. And simply check about that feature. Okay. Suppose this image, you can get the image for that. You can see 1990 1st April. Okay. Also you can get another image 2020 1st. Okay. And in this time it should look like that because in this time I also set the date about that. You can see. So I set the year, month, and put here the first. Okay. First, suppose 1st January 2000, 1st February 2001. So this type of things in this time. So if you want, you can also put here the specific time about that, or if you want, you can also cancel it. Suppose in this time we don't need. Okay, so we remove that. Okay, so now let's check the code again. Suppose click on here. In this time it show the result for 2001. Median month is January. Suppose click on here. 2001 month is February. Select the February, month of February, median image. Suppose I click on here. We get the 2001 March, and also you can get the result for 2001 April. Okay. So in this time it show the individual monthly image collection. Suppose month. Suppose also you can see the result. So it show the result for 2004. Suppose February. Also you can see the result for the image 2004 March. Okay. So in this time it show the result for suppose yearly and specific month. Okay, so when you use this type of code, so mainly in this time, first of all, it created the yearly image collection or annual image collection, and after that, we also add the monthly. Okay, suppose for a specific month, suppose January to April. Okay, 1 to 4, which I set in here, I can get the result. Okay, so in this time we can get the result look like that. Or if you want, you can also create the another thing. Suppose you just need only for the only for this image. Suppose January to April median image collection. January to April, not each month. Only for that median image collection. For that January to April. Suppose 2000 to 2010. So this type of things. Okay. Further we have to use another way. Okay, suppose I show you that. It mainly show the yearly with a specific month. Okay, so 2004 month of March. This type of things you can get. In this time you can see 2005 February. Okay. Okay. Any question? Okay, any question, please?
We're okay, we are following it up.
Okay. As well as we also suppose in this time. Okay, so in this time, suppose you want to create. Suppose you want to create and filter the image collection with a month range of each year. Suppose a specific year you want to filter the image collection for with a month's range. Okay, so further we have also used another example. Suppose in this time, first of all, you can simply, okay, I'll show you that, just a minute. Okay, so suppose, okay.
Can you perform the code for a mean image for these 5 months?
Suppose in this time, April to, suppose I put here that, suppose May. Okay, April to May, we can get suppose April to May, we can get the result for each year. 2000, suppose monthly. In this time, it show the monthly. Or if you want, you can also show the another way. Suppose you filtered the image collection with a month range for each year. In this time, this is my month range, January to April. So I want to use that the January to April. This is my specific range for each year. Each year, median image collection I need to create. Okay, or each year,
it will show the median image for these 5 months, but we want that only one image for these 5 months only. Median of these 5 months.
Yeah, so you want to use at the 5 months, suppose January to April. These 5 months median image collection for each year. Is it okay?
Yes, sir.
Okay. So I show you that in this time how we can easily filter that. So for that we already define about that our start year, and also put here the end year. Okay. As well as we are also put make the list sequence about that. Suppose start month and start. Okay, so you can see start is that we can put here that January to April. Okay, so now how we can easily create about that. So first of all, we have to just make the same process also in here. and basically it show only for the annual. Okay, and you can simply put here the suppose we can simply put the ee.image collection from image. Okay, and then first of all we have to call about that years. Okay, so mainly which specific years in this time 1992 2021. Okay, years. Then put here the map function. Basically in this time I need to create a function, so in this time I just put here the function is the y. Okay, and put here that function, put here the word, and then put here that we just move the argument about that in this time. Okay, so okay, so let me take the another what I simply remove that. Suppose okay, I did the from the first take a variable. Suppose put the variable name is the monthly image. Okay, so for that just use the same function ee dot image dot image collection dot from image, okay, from images. And now first of all I define my years, so just put here the years which I already defined my specific years, and then put here the map. Okay, in this map I want to add my function, so put here the function keyword. In this time suppose I use here the suppose year. Okay, put here the year directly. I use here the year as element name. You can put any element name, there is no problem. And then I define here the my argument. In this time my argument is that I define the argument. Suppose take a variable, suppose start date. I simply put it the start date. In this start date I simply use the ee dot date from year month day. Okay, year month and day. So in this time suppose I put here the year. Okay, suppose in this time I just simply use here the same element name year, and then put here the start and end about that. So okay, so start and end. Okay, so in this time when you want to use at the ymd, we need the three argument. Okay, so in this time we are also take the another thing. Suppose in this time before make the sequence we just take the variable. Suppose take the variable, suppose start month, suppose 1, and take the another variable, suppose end month. Put here the suppose 5. Okay, thus we can separate, and then we make the list about that. Just take the variable. Okay, so now I simply copy the start month. Okay, so here okay, put here the start month, and then set the date. Suppose first. Okay, first date, and also put here that another variable. Suppose take a variable. Suppose in date. Okay, and put here the ee dot date dot from ymd. Okay, and then same approach we are also put in here. In this time just okay, so in this time if you want you can simply put here the er, or if you want you can also add here the suppose ee dot number, and in this number I simply call the er, and this er add a advanced one. Because suppose mainly in year will be suppose year of 2020 last date about that. Okay, last it will be last for the increase the 1 year about that, and then also define here that in month. Okay, so in month which is May, put here the in month, and then put here the day about that. Suppose I put here the day for the 30. Okay, so 30 day in date, and then finally I just need to call my collection. Okay, so just simply take a variable. Suppose I call the variable name is that, suppose annual, and simply call my collection. Suppose this is my collection, okay, which is including total 439 images. Paste in here, and then I simply use a function filter date. Okay, and now I put here my start date, which I already defined. Paste in here, and also put here that end date. I already defined about that. Okay, start and end. Okay. Okay, so now we have to set what I need. In this time, I need the median image collection. So use here the median. So in this time, what happened? In this time, each month we can get the median image collection from January 1st to April 30. Each month. Okay, median. So I use here the median. Okay, not only in this code, not only for the image collection, you can for any time series chart or any purpose for a specific year, a specific range, we can use the same code all time. Okay, so now I take the median image, so I use here the median. Sometime when you want to work for that, suppose NDVI, suppose you need the, you can use here the average, or use here the mean NDVI. Suppose you need the total precipitation, then use here the sum. Okay, this type of things will be changed according to your purpose. So in this time, I just simply return from here. So just use here the return function. From this function, I return the two things. Okay. First of all, I select the year. I get the annual. Mainly, I want to add the year as well as also the month. Okay. So return this variable. So use here the annual, and then put here the set with year, and put here the year. Okay, and also set the another thing is that dot set. In this time, okay, in this time you use here the system time start, and then also put here the, suppose you can put here the ee dot date from year, month, day, year. So year, then put here that, suppose January, suppose 1st January. And finally, we just also set the format about that, how, what the format you want to use. You can use any format. So for that format, just use here the format option, and then you can simply use the format. Suppose you want to use here the YYY, okay, year underscore month underscore day. So it's a lowercase day. Okay, so now finally it created the, so just I simply copy the variable and paste here and click the run. So now let's check about that what we can get. In this thing I get the 32 years. Okay, so because in the 32 years, but 32 years, which is my month, specific month, January to April, median image collection for 32 years. Okay, in this time this image collection is created for that January to April, which I said for the 32 years. 32 years for a specific month of range, which I set in here, start month and in month. Okay, so now from that we can easily make this image and then make the not only for that, make the, suppose NDVI or any image collection. We can easily convert any image collection using the same code. Okay, just we can simply set the start and end date, then it automatically work. Okay, so in this time I also, okay, so this is the code about that, and using the same code you can easily do for any other image collection for filtering the image collection with the month range for each year. Okay, a specific year for a specific range. Suppose in this time we have put the range for January to April, and then filtered this image collection. Okay, so I hope you can got the answer. Okay, so basically this is the process about that, how we can easily find out the filtering the image collection for a with a specific month range for each year. Okay.
Okay, sir.
Okay. Okay, so I also send you the code about that. So in this time I simply just commenting this the code. Okay, in this time it not need for my side. So in this time I just created the annual image collection. Okay, so annual image collection I created. So just use this function and then put here. It's only for the I just work for the only for the year, and year mainly January to December. Not not put any specific range about that. Okay. So now from here, I need to show the image. So basically, it show the image for total 32 years. Suppose in this time I need the image for 1990, 2001, 2011 and 2021. Okay, so for that I need to filter the specific year from the annual collection. Okay, from this annual collection I need to filter the specific image. So now how I can filter about that, in this time I try to discuss about that things. Okay, so for that just I should show the same process for that. Suppose I simply copy from here this code and show you that. Simply copy. Simply paste in here. Okay. So now from here you can see annual image collection, which contains total 32 years image collection. Okay, in the annual image collection contains total 32 year image collection. So from here I just want to show the image